Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 5 of lesson number 4, structure of the atom. So in this part, we will be studying about as we are only left with atomic mass, then we have mass number, then we are left with isotopes and isobars, right? So we will be discussing on them in this part, and make sure before I start with atomic mass, you know what exactly you can say the previous part that we have studied. You should be knowing the postulates and everything. Okay, so you have to be sure and make sure you know everything. So I want each one of you to please revise what we have studied so far in the lesson. Okay. I hope every one of you have started revising whatever we have studied so far in the lesson. So I hope every one of you have started revising whatever we studied so far in the lesson. Now I want each one of you to please go through the slide. So you have to go through this slide because this is what we started the lesson with, right? So I want each one of you to please go through it once. I hope everyone is going through this slide. After this, we discussed on what are like charged particles in matter. So I want each one of you to please go through it once about the charged particles. We know that atoms, like they have three types of subatomic particles in them, which includes electrons, protons, and neutrons, right? So please go through this. So here we have information on electrons, protons, and neutrons which has been given. I want each one of you to please go through it once. I hope everyone is going through it. Even you need to go through the figure that has been given. So make sure you all know it very nicely, okay? After this, we discussed on like for understanding the nature of charged particle. We carried on this activity, right? So I want you all to please go through this activity. After this activity, like this is what the brief explanation on activity all about, and as I'm repeating it from every part, that this is one of the most important slide where we have information on, you can say, E Goldstein, who has like came up with the canal rays, which are considered to be, you can say, positively charged radiation, right? So this subatomic particles, they have charge which are equal in magnitude and opposite in sign. So like if you have to differentiate between protons and electrons, like that is the differentiation which has been given over here, that they are equal in magnitude, opposite in sign, and its mass is approximately 2000 times as that of electrons, right? And mass of proton, we consider that as 1 unit, and the charge has been considered as +1, whereas mass of electron is considered to be negligible and its charge is -1. So I want each one of you to please go through this slide once. I hope everyone is going through this slide properly. Now, as I am repeatedly telling you that this slide is important, make sure you know the names who have introduced electrons, who have introduced protons and neutrons as well. Because if you remember, we have studied about neutrons in the last class, right? So you should be knowing about neutrons as well, like who has exactly introduced neutrons. Then after studying this much, we studied about the structure of an atom, right? So here we have Dalton's atomic theory that we have discussed, and how electrons and protons are been arranged in the atom. We even studied that over here. So I just want you all to please go through this part. Sorry. After this, we discussed on Thomson's model of an atom. So Thomson's model is also called as plum pudding model, right? So this is how you need to represent how exactly Thomson's model of an atom looks like, which has a positive sphere, and inside that positive sphere we have electrons which have been present. Always remember that Thomson gave a perfect example considering a watermelon, where he told that the black seeds in the watermelon that act as electrons, and the red part is the neutron, which includes protons and neutrons. The red part is the nucleus. Okay, so this is how it works. So I just want each one of you to please go through this slide once. After this, we discussed on who exactly J.J. Thomson was, right? So I want each one of you to please go through this slide as well, because you should be knowing about them as well. After this, we discussed on what exactly Thomson proposed, right? So I just want each one of you go through this, because you should be knowing what exactly he had proposed. Okay, So after this, we discussed on Rutherford's model of an atom, right? So I just want you all to please go through it. So here we have the reason why exactly you can say a gold foil was used by Rutherford, and even along with the gold foil why the alpha particles were used. Okay, so I just want each one of you to please go through it once. I hope everyone is going through this slide. I hope everyone is going through this slide. After this, now these are some of the unexpected results which were like observed and like which was found out by Rutherford, where he saw that some of the alpha particles they pass straight through the gold foil, while some of the alpha particles they got deflected by the foil by small angle. Okay, so this were some unexpected result. Rutherford was not expecting such results, and surprisingly, what happened is one out of every 12,000 particles they appeared to rebound. Okay, so in the words of Rutherford, this result was almost as incredible as if you fire a 15-inch shell at a piece of tissue paper and it comes back and hits you. Okay, so this is what Rutherford has came up with, like the results that he got was this. So I just want each one of you to please go through it once. After this, like we have information on Rutherford which has been given. So I want you all to please go through this once. After this, we discussed on the drawbacks of Rutherford, on which like Bohr's model was worked on, right? So I want each one of you to please go through this drawback of Rutherford's model. After this, the drawbacks, like we had Bohr's model. So Bohr was the one who was working on the drawback of Rutherford. So I want you all to please go through it, go through this Bohr's model of an atom once. After this, we discussed on who exactly Neil Bohr was. So I just want each one of you to please go through it once. After this, we discussed about these four shells, which are very important because, like, when you write about the electronic configuration and all, right, you have this electronic configuration maybe in next year in 10th. Okay, so that time you should be knowing about the shells, that how many electrons K shell can have, how many electrons L shell can have, how many electrons M shell can have. So those basic details should be known by you. Okay. After this, we discussed on what are neutrons. So I want each one of you to please go through this. I hope you all are going through this, like how exactly the electrons have been distributed in different orbits, because we have K shell, L shell, M shell, and N shell, right? And like based on the formula 2n square, this electrons have been distributed in different orbits. So I want you all to please go through it quickly. So here, like as I said, that K shell can have only 2 electrons, right? L shell can have 8 electrons. M shell can have 18 electrons, and N shell can have 32 electrons. So these are the number of electrons which can be present in a particular shell. But we are not calculating it on its own, right? We are calculating it on the base of the formula 2n square. So you should be knowing how to calculate that. So I want you all to please go through it quickly. After this, like knowing how the electrons have been distributed in different orbits, this is how the schematic of the first 18 elements have been given. So I want you all to please go through it. Then now we need to discuss about valency. Okay, I just forgot about valency while saying I didn't told you about valency, right? So like we have to discuss about valency, then we will be discussing on atomic mass, mass number. After that, we will be discussing on isotopes and isobars. So these are the 5 different topics that we are left with, right? So let's start discussing about valency. So you know now how the electrons are been arranged in different shells, right? So we have learned how the electrons in an atom are arranged in different shells or orbits. So the electrons present in the outermost shell of an atom, we consider that to be as the valence electron. Got it? So the electron which is present in the outermost shell of an atom, because we know an atom can have like, it depends upon the atomic number, and on the basis of that we make that we make that atom like it has K shell, L shell, M shell, and that is how. So whatever like, if you can see the first one for hydrogen, if you can see the K shell has only one electron, because we know the atomic number of hydrogen is 1. So it is like incompletely filled. Hydrogen needs one more electron to become stable, because K shell needs 2 electrons, right? And helium has 2 electrons. So helium is the stable atom because the number of electrons which has been required is there, right? But when it comes to lithium, can you see the K shell has 2 electrons? Okay, the L shell that it has only 1 electron, and we know L shell needs 8 electrons to get stable, right? So what can be done by lithium over here is the lithium is going to like lose its 1 electron so that it becomes stable, because gaining 7 electron will require more amount of energy, right? So what lithium will do, instead of gaining 7 more electron to become stable, lithium is going to lose that electron and it will become stable with 2 electrons in the K shell. Getting it? So now because lithium has 1 electron in its outermost shell, the valency of lithium becomes 1. Now beryllium has 2 electrons in its outermost shell, so the valency of beryllium becomes 2. Boron has 3 electrons in its outermost shell, so the valency of boron becomes 3. When it comes to carbon, because carbon has 4 electrons in its outermost shell, the valency of carbon becomes 4. Then same goes for nitrogen, it becomes 5. Okay, so this is what valency is. Okay, so the electrons present in the outermost shell of an atom, they are known as valence electron. Always remember this, that whatever number of electrons are present in the outermost shell of an atom, we know that as valence electron. Okay, so from the Bohr-Bury scheme, we also know that the outermost shell of an atom can accommodate a maximum of 8 electrons, right? Because that is according to the Bohr-Bury scheme. The outermost shell can have maximum 8 electrons in it, and it was observed that atoms of elements completely filled with 8 electrons in the outermost shell show little chemical activity. Now if there are certain atom who has 8 electron in its outermost shell, then they show some chemical activity over there. So in other words, their combining capacity or valency is going to be 0, because they are stable. They have 8 electron in its outermost shell, and we know L shell requires 8 electrons to become stable, right? And according to Bohr-Bury scheme, we don't add 18 electron and 32 electrons in the outermost shell. Okay, we just add till 8. So if it is stable, it has 8 electrons in its outermost shell, it means its valency is 0, because it doesn't require any more electron. Okay, it is neither going to gain or it is neither going to lose it. So of this inert elements, the helium atom has 2 electrons in its outermost shell, and all the elements have atom with 8 electrons in the outermost shell. Now as I said, helium has only K shell, and the K shell is completely filled. It is stable, right? So the valency of helium is 0 again. Got it? So the combining capacity of the atoms of elements, that is the tendency to react and form molecule with atoms of same or different element, was explained as an attempt to attend a fully filled outermost shell. So this was like an attempt to find out about elements and molecules in detail, and an outermost shell which had 8 electrons was said to possess an octet. Okay, if the outermost shell of an atom is 8, we call that as an octet, and atoms will thus react so as to achieve an octet in the outermost shell. Okay, I hope everyone is like writing the things from the screen like on valency. Please do take a note of everything that you find important on screen. I hope everyone is writing all the important points from screen. Now after this, see, this was done by sharing, gaining or losing electrons, and the number of electron gained, lost or shared so as to make the octet of electron in the outermost shell gives us directly the combining capacity of the element. What does it gives us? It gives us the combining capacity of an element. So that is the valency discussed in the previous chapter. So for example, we have over here like hydrogen, lithium, sodium atoms. They contain one electron each in their outermost shell. How many electrons do they have? They have one electron each in their outermost shell, and therefore each one of them can lose electron. Got it? So they are said to have valency of 1. Now because they have one electron in their outermost shell, that is why we say that their valency is 1. Okay, now what will be the valency of magnesium and aluminium? Now because we know that the number of electrons in you can say magnesium is 2 in the outermost shell, the number of electrons in the outermost shell of magnesium is 2, so the valency will become 2. When it comes to aluminium, the number of electrons in aluminium is 3, so the valency will become 3. Okay, so this is how we write the valency. So if the number of electrons in, you can say, in the outermost shell is of an atom is close to its full capacity, then the valency is determined in different way. For example, like if we consider the fluorine atom, fluorine has 7 electrons in the outermost shell, and there the valency will become 7 because it has 7 electron in its outermost shell. Okay, but it is easier for fluorine to gain 1 electron instead of losing the 7 electron. So what fluorine is going to do over here? Fluorine is going to gain 1 electron instead of losing 4 electrons. Got it, everyone? So they are going to gain 1 electron, and hence the valency is determined by subtracting 7 electrons from its octet, and gives you a valency of 1 for fluorine. So valency can be calculated in similar manner for oxygen as well, in the same way. Getting it? So what is the valency of oxygen that you get from this calculation? If you calculate it, we know that uh, oxygen का 16 है, right? So 2, 8, 6. So what oxygen is going to do? Donating 6 electron is going to take much energy. So what oxygen is going to do? It is going to take 2 electrons. So the valency of oxygen becomes 2 over here. Got it? So now here we have the definition of valency which has been given. An atom of each element has a definite combining capacity, and we know this combining capacity of an element as its valency. So the valency of first 18 elements is given in column 4.1. So we have this table which we will go through, but before that I want you all to please go through the slide. I hope every one of you are writing all the important points from screen. After this valency, like we have atomic number, mass number. So let's see if I can start with it. I hope every one of you have taken note of all the important points that we have. Now over here in this table, we have the composition of atoms of the first 18 elements with electron distribution which has been given. Okay, so here we have elements starting from hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. So you should be knowing the first 18 elements first of all. And once you know about the first 18 elements, after that you should be even knowing about the symbols, like what kind of symbols do we use for them. Okay, so for hydrogen we write it as H, helium we write it as He, lithium we write it as Li, beryllium is written as Be, boron as B, carbon as C, nitrogen as N, oxygen as O, fluorine as F, neon as Ne, sodium as Na, magnesium as Mg, aluminium as Al, silicon as Si, phosphorus as P, sulfur as S, chlorine as Cl, and argon as Ar. Okay, you should be knowing all the symbols and then the atomic number that has been given starting from 1 to 18. I hope everyone is going through it. Even we have the number of protons, neutrons, electrons given, how they have been distributed, you can say in the K shell, L shell, M and N shell, and the valency of it has been given. So I want you all to please go through it once. I hope everyone has been through this slide as well. Now, after this, we have atomic number, which I'm not going to continue today. Okay, I'll start with atomic number and mass number in the next class. After studying atomic number and mass number in detail, we have isotopes and isobars to discuss. Even we will be discussing the differentiation as well, like how isotopes are different and what are the application of isotopes. We'll even discuss that in detail. After that, we will be even discussing on isobars in detail. Okay, so after that we will discuss on isobars, what are isobars, and then we have the summary discussion in detail, what exactly what exactly we have studied in the whole lesson structure of an atom. So I want each one of you to just have a quick glance through it, and then we'll move to the next part. Then we have some of the exercise questions to discuss. So I just want you all to please go through it once. So we have altogether like 19 questions to discuss, which we will be like doing at the end of the session. Okay. So isotopes, like while we study about isotopes, you will come to know how to exactly like calculate the formulas and all, everything will be known. Okay. So this is how we will be like ending up with the lesson structure of the atom. And I hope whatever we discussed today in the lesson structure of atom, you're very much clear with it. Now the rest of the part which has been left, like the atomic mass, the mass number, then we are left with isotopes and isobars. So we will be doing that in the next part. Okay, so please do revise each and everything that we have studied so far in the lesson structure of an atom. Thank you everyone.